The Kuiper Belt is often considered the frosty home of countless comets and minor planets, yet astronomers have only recently begun to uncover its hidden secrets. In fact, the existence of this cosmic ring of icy chunks was only confirmed in 1992, and there is even speculation that a large, completely unknown planet might be lurking out there. To delve deeper into the mysteries of the Kuiper Belt, the James Webb Space Telescope, JWST, recently turned its gaze toward this remote region and made a sensational discovery: some of the celestial bodies there could actually radiate heat and potentially even harbor life. The remote outer regions of the solar system still hold countless blank spots on star maps. For a long time, the only thing we knew about this distant area was that the origin of comets must lie dormant somewhere beyond Neptune's orbit. The specifics of what kind of formations exist out there, and whether there are any significant celestial bodies, remained an unsolved mystery for decades. One of the first scientists to tackle the mystery surrounding the source of comets was Dutch astronomer Jan Hendrik Oort in 1950. Oort proposed a model based on a spherical zone at the outermost edge of the solar system, which he suggested serves as a natural reservoir for comet nuclei. According to his theory, every time this cloud is influenced by the gravity of interstellar gas clouds or nearby stars, some chunks are knocked out of their orbits and become periodic comets. However, Oort's explanation only accounted for the orbits of long-period comets, which have random distributions and are often highly inclined to the planetary orbits. This model couldn't explain the characteristics of short-period comets, like Halley's Comet. Recognizing this gap, astronomer Gerard Kuiper in 1951 hypothesized the existence of a second comet reservoir, closer to the Sun, taking the form of a gigantic ring of icy debris just beyond the orbits of Neptune and Pluto. Although Kuiper's hypothesis provided a plausible solution on paper, it couldn't be proven for decades. The telescopes available at the time simply weren't capable of detecting smaller celestial objects at such vast distances. It wasn't until 1992 that Kuiper's assumptions were finally realized. Using the Mauna Kea Observatory in Hawaii, astronomers Jane Liu and David Jewett spent 5 years searching for evidence and finally identified the first trans-Neptunian object from the Kuiper Belt, 15,760 Albion. Today, we know that this ring-shaped, relatively flat region outside the orbit of Neptune extends for about 30 to 50 astronomical units, AU. To put that into perspective, 1 AU is the average distance between the Earth and the Sun, roughly 150 million kilometers. Beyond this zone, the Kuiper Belt gradually merges into the inner edge of the Oort cloud. This frosty reservoir is approximately 20 times larger than the asteroid belt between Mars and Jupiter and up to 200 times more massive. The heart of the Kuiper Belt is believed to contain over 70,000 objects with diameters greater than 100 kilometers. However, smaller bodies remain invisible even to powerful space telescopes like Hubble due to their enormous distance from Earth. It wasn't until 2019 that a team of researchers successfully detected a Kuiper Belt object with a diameter of less than 10 kilometers. This 1.6-kilometer lump provided proof that smaller bodies do exist in the Kuiper Belt, but we're still far from understanding how many objects it truly contains. What we do know is that the Kuiper Belt is home to several dwarf planets, which ultimately led to Pluto's reclassification from a planet to a dwarf planet in 2006. After more Pluto-like bodies, Plutoids, were found in the Kuiper Belt, the International Astronomical Union decided to redefine the term planet, which led to Pluto being demoted. However, there is growing evidence that another, larger celestial body may be hiding in the Kuiper Belt, possibly even deserving of a place in the traditional planetary category. The idea that a large, undiscovered planet, often referred to as Planet 9, may be slumbering in the outer reaches of the solar system has been gaining traction. The first indications of this hypothetical planet were provided in 2015 by the orbits of 6 larger objects in the scattered disk area of the Kuiper Belt. Astronomers noticed that dwarf planets like Sedna exhibit eccentric, highly elliptical orbits with their main axes pointing in the same direction. Additionally, their orbits are inclined by around 30 degrees to the plane of the ecliptic, the apparent path of the Sun across the sky. Following this discovery, other Kuiper Belt objects were found with similar orbital characteristics. This led scientists like Mike Brown from the California Institute of Technology to argue that these similarities are not coincidental. Brown estimates the probability of this alignment happening by chance is only 0.7%, strongly suggesting that these celestial bodies are being influenced by the gravitational force of one or more massive objects. But what could be responsible for this gravitational effect? One theory is that the Kuiper Belt objects influence each other through their collective gravity. However, for this to be the case, the Kuiper Belt would need to be 100 times more massive than generally assumed. Another hypothesis is that the Kuiper Belt contains a ring structure made up of many smaller chunks whose combined gravity could cause the observed orbital anomalies. The most exciting explanation, however, is the existence of a previously undiscovered planet in the Kuiper Belt. According to model calculations, Planet 9 would have about 10 Earth masses and a diameter slightly smaller than Neptune's. It would orbit the Sun at a distance of between 400 and 1,500 Australian dollars, making it, on average, 20 times further from the Sun than Neptune. Completing a full orbit would take this planet a staggering 15,000 years. Brown believes there is more than a 90% chance that Planet 9 exists, but it remains hypothetical because it hasn't yet been observed directly. Why hasn't Planet 9 been detected despite humanity's long history of skywatching? The answer might lie in its current position, which could be at the farthest part of its orbit from the Sun, rendering it nearly invisible even to the most powerful telescopes. Additionally, Planet 9's intrinsic luminosity might be extremely low, around 0.006, compared to Neptune's 0.01, making it even harder to spot. Its emitted radiation would likely be in the infrared range, meaning its temperature could be as low as 47 Kelvin, or minus 226 degrees Celsius. This makes Planet 9 best detected in the far infrared spectrum. While the hunt for Planet 9 continues, the James Webb Space Telescope has recently made a groundbreaking discovery in the Kuiper Belt. The remote area, once thought to be a cosmic no-man's land of dead, icy objects, might actually harbor conditions that could support life. This revelation challenges long-held assumptions about the Kuiper Belt being an inhospitable region. A study led by Christopher Glaine's team from the Southwest Research Institute focused on two dwarf planets, Eris and Makemake. The researchers found evidence of frozen methane that had only recently been heated, suggesting the presence of hot cores within these frosty dwarf planets. This discovery implies that these bodies might be capable of transporting liquids and gases to their surfaces, a finding that hints at the potential for subglacial oceans beneath their icy exteriors. The existence of such oceans has already been proven on other icy moons in the solar system, such as Europa, which raises the possibility that some of these Kuiper Belt objects could offer conditions conducive to life. Although this remains a theoretical assumption for now, it provides a compelling reason to further explore these cosmic frontier regions. The recent data from the James Webb Telescope adds a new layer of intrigue to the Kuiper Belt. NASA's New Horizons mission to Pluto has already shown us that this distant region is far more dynamic than previously thought. The discovery of complex topography and diverse geological features on Pluto suggests that the Kuiper Belt could hold many more surprises. The Kuiper Belt, long regarded as the frosty home of countless comets and minor planets, has remained one of the solar system's most enigmatic regions. Discovered in 1992, the Kuiper Belt stretches from about 30 to 50 astronomical units, AU, from the Sun, and it contains a wealth of icy bodies, including dwarf planets like Pluto. Initially theorized by astronomers Jan Hendrik Oort and Gerard Kuiper, the existence of this distant belt was confirmed with the discovery of 15,760 Albion. Despite its discovery, many aspects of the Kuiper Belt remain a mystery. Researchers have only recently detected smaller objects in the belt, such as a 1.6-kilometer body in 2019, and questions about the belt's total population and its structure persist. The recent observations by the James Webb Space Telescope, JWST, have unveiled unexpected findings in the Kuiper Belt. Contrary to earlier beliefs that this region was inhospitable and lifeless, evidence suggests that some of its celestial bodies may harbor conditions suitable for life. The JWST detected evidence of recent heating on dwarf planets Eris and Makemake, implying the presence of internal hot cores and potentially subglacial oceans. This revelation challenges our understanding of the Kuiper Belt and opens new avenues for exploring the potential for life beyond the inner solar system. The ongoing search for a hypothetical large planet, known as Planet 9, further underscores the dynamic and mysterious nature of this remote cosmic region. The Kuiper Belt, which lies beyond Neptune's orbit, is believed to be a vast, ring-shaped region containing numerous icy bodies. This area was first hypothesized by Gerard Kuiper in 1951 as a reservoir for short-period comets and later confirmed in 1992 with the discovery of the first trans-Neptunian object, 15,760 Albion. Spanning approximately 30 to 50 Australian dollars from the Sun, the Kuiper Belt is home to many objects, including several dwarf planets like Pluto. Despite its extensive study, many aspects of the Kuiper Belt, such as the total number and size distribution of its objects, remain elusive. The quest for understanding the Kuiper Belt has led to intriguing discoveries and hypotheses. The existence of a potential large, undiscovered planet, dubbed Planet 9, has been suggested to explain the peculiar orbits of some Kuiper Belt objects. According to this theory, Planet 9 could be up to 10 times the mass of Earth and orbit the Sun at a distance ranging from 400 to 1,500 Australian dollars. Despite these intriguing possibilities, the planet remains hypothetical due to its faint luminosity and extreme distance, making it challenging to detect even with advanced telescopes. The ongoing search for Planet 9 highlights the dynamic and mysterious nature of the outer reaches of our solar system. The Kuiper Belt is a critical region in our solar system, known for its icy bodies and potential to reveal new insights about the early solar system. It extends from roughly 30 to 50 Australian dollars from the Sun and is home to numerous objects, including several dwarf planets like Pluto. Though discovered relatively recently, in 1992, the Belt study has provided valuable information about the solar system's formation and the distribution of small celestial bodies beyond Neptune. To better understand the geological context of these discoveries, Blaine hopes that NASA will send another probe into the Kuiper Belt in the near future. Such a mission could reveal wonders that we can only imagine today. As we continue to push the boundaries of our knowledge, the Kuiper Belt remains one of the most promising and mysterious regions to explore, with the potential to rewrite our understanding of the solar system.